And we're back. Let's talk about problem number 3 from page 389. It's talking about someone in a boat and they're rowing with the water and against the water. Now, it's kind of hard when you are actually rowing with the water, okay, or downstream, okay? So with the water, downstream, the water's helping you, it's helped pushing you, it's making you go faster. So it's kind of confusing. When it's downstream, you actually want to do an addition problem. So it says when the person's rowing downstream with the water, they were going 5 miles per hour. When they're going upstream, if I can spell, there we go. Upstream, that's actually when they're going against the water. So it's kind of confusing because down you think negative, up you mean positive, but you got to think about what you're doing. Downstream is when you're going with the water. Upstream is when you're going against the water. So the nice thing about these wind and current problems, there's also wind problems where there's like an airplane going with the wind or against the wind, is that there's opposites right here. There's a plus W and there's a minus W. So these problems are actually very, very easy to solve, okay? So what I would do if I were you, I would just add to the left and add to the right and see what's left over. So the W's would cancel, okay? With the water, against the water, it all cancels. You'd have 2 R's left over. 2 R's equals a 5 plus 2, which is a 7. You divide by 2. Sounds like the rowing speed, you the human power, you are rowing at 3.5 miles per hour, okay? Then you would plug that number back in. Well, how fast is the water, the current? And variables are interchangeable. I used R for rowing and W for the water speed. You could use C for the current, whatever. It's all interchangeable to me. The speed of the water, mental math, let's see, add it to 3.5 to make 5 or subtract it, 1.5. The water speed, or the current, I guess you could say, is 1.5 miles per hour, okay? So again, the thing that you're going to struggle with is when they say downstream and upstream, okay? So remember, upstream is against, subtraction, the water. Downstream is with the water, okay? The got it question to problem 3 is pretty slick. Haha, water joke, whatever. All right, so it says upstream, okay? It gives you just a straight up upstream question. Upstream. Wow, where did the D come from? That was really weird. Upstream, okay? It says you, the human, can row 3 miles per hour. You're at your fastest. At your fastest, you can row 3 miles per hour. But the stream is moving at 4 miles per hour. So it says, with this math situation, with both of these speeds, what's going to happen if you try to go upstream? Well, mental math, it's like, well, the water's faster than you. It's more powerful than you. It's probably going to beat you. Yeah, exactly. So here's what's going to happen. If you row 3 miles per hour and the water is pushing you back at 4 miles per hour, you're going to be going backwards. So no matter how hard you try, you're going to be going downstream. It's going to, even though you're trying to go upstream, you're trying to go upstream, but since the water resistance is faster than you, you're going to be moving backwards. Okay, so even though I told you before, sometimes you can get negative answers. Okay, that's, time, it's kind of hard to go backwards, but you can definitely go backwards when you're trying to go against a current. So if the water is moving faster than you can row, you're going to be moving backwards. So -1 miles per hour downstream. You're going to look very silly while they do that. Okay, kind of reminds me of indoor swimming pools. Some indoor pools have like a wave generator, or it's almost like a water treadmill where literally it's the person swimming, okay, person stick figure, and there's some type of machine right here, and it's kind of a nice thin lane, but the machine pushes the water this way, so you basically swim in place. It's kind of, like I said, it's kind of like a treadmill for water, a water mill, if you will. But they have to adjust the speed here, so I'm sure there's some type of mechanical box with buttons on it, or some type of crazy sweet lever that you just move back and forth, faster or slower. But yeah, so for this person to stay exactly in one spot, their stream and their speed would have to be equal if they want to stay in one spot. So if they're going backwards, that means they're swimming slower than the water speed. If they're getting too close to where the waves are being generated, then they're swimming too fast. So that's what it reminds me of, it's this situation. So, but for this swimmer to stay in exactly one spot, the machine's got to be equal to their speed. There might be some super fancy ones that measure the human speed, and if they see them getting too close, maybe they turn up the speed, or if they see they're falling too far back, then they turn. I don't know. I'm not a treadmill swimmer person. So there you go. Anyway, that's about it for the upstream wind current problems. Okay, set them up carefully. You can solve with opposites or just answer basic math questions with a nice little setup, and then make sure you explain your answer. All right, see you in class.